All right. So today I want to we are going to interview. I'm going to interview Andrew Haun, who is the co-author of Haun and Tononi paper in 2019, Entropy, about the space. And in particular, I'm interested in asking Andrew about the relations that are introduced in that paper, right?
Yeah.
For the first time. So, Andrew, I wanted to ask you about the relations in sort of the broader kind of level, and also medium level, which I'm thinking as a sort of the why do we need relations for the space?
Yeah.
Broader level is why in the hell, in the heck, we need the relations. And then at the sort of the narrow level, I want to ask about sort of specific kind of computation or philosophy behind each of these definitions and so on.
Okay.
So maybe you can
probably
start with the sort of a little bit of the history of maybe how did it came out. That's probably interesting to hear.
Yeah, so I guess this is in the context of IIT, right? So it's not just relations; it's relations as a part of integrated information theory, right?
Yeah.
So as of like 3.0 or before then, IIT starts talking about composition, right? That this is a basic property of experience, is that all experiences are composed of many different parts, aspects, whatever. And you can think of that as being modalities, or you can think of it as being like the most kind of elemental, like pixels of a visual field or something like that. These are all parts of an experience, and they're put together in some way. And with 3.0, 3.0 came out with this idea of taking a system and looking at it as a set of mechanisms that exert causal constraints on the system. And that's the cause of, I think then, I don't remember what it's called anymore. That's the cause effect structure or the conceptual structure. And that's the whole thing. You find big phi and whatever, and that tells you which system is specifying this conceptual structure. But that's the whole thing. It's a bunch of mechanisms and their causes and effects. And that was supposed to capture composition, that you have all of these different parts. And when you look at it, you see that they're overlapping. The mechanisms overlap with each other. They're made up of common units, and the causes and effects overlap. But there's nothing that overlap isn't really an explicit part of the structure, right? In terms of what exists, like the maximally reducible causes and effects and so on, that's what existence is for IIT. The overlaps themselves are implicit, right? And so it's hard to say that the overlaps between all of these different parts actually exist for the system, strictly according to 3.0.
Yeah, maybe let me ask a bit about the clarification. So overlap that we are talking about is that when the mechanism look at the past or future, they constrain the same kind of system or overlapping part of the system. That's what you mean by overlap, right?
Yeah, you might have two mechanisms and they exist by virtue of the fact that they have irreducible causes. And those causes exist for the system because they exist for the mechanism. And the system is made up of mechanisms. But if those two causes overlap, like if the two mechanisms are constraining some of the same units, then for 3.0, that fact that they overlap is not really explicitly there in the cause effect structure. You can kind of, I think the idea was that there was a, with the EMD, the Earth mover's distance, you can think of all of these different causes and effects as being located in a cause effect space. And a lot of the 3.0, like the 3.0 papers and all of other papers would show all of these the concepts arrayed in a space where all of the axes are different states of the system, different possible states.
Mm.
And so I guess the idea was that what the relations are somehow like distances between concepts, or if two concepts are on similar axes, then that somehow would capture the relations. I think
that's where it came from.
Yeah. So the job of relations for 3 points, it's not like it's not like they didn't think of it, but I think the idea was that the job would be done by having this common state space that everything is located in. That's what relates everything. But really, when you look at it, the state space itself doesn't exist for the system. There's no, according to the definitions, all the postulates and so on, they're all about mechanisms and their causes and effects. There's no postulate that says that there is a state space that exists for the system, right? So it's all implicit. These are all, so that doesn't really do the job of defining relations in a way that.
Okay.
So what relations are, I guess I said overlap before, that's still kind of too broad. What it is more specifically is overlap of units in the same state. So it's, what a relation is common composition, right? So if the causes and the effects are made up of the same thing, and what a cause or an effect is made of is units in a certain state. And so if the cause and the effect are on the same units in the same state, then they're composed of the same thing. And then I guess you can go another couple of steps past that, and then you can ask questions that I don't think anyone has a clear answer to. Like, it's like, what is, I don't think that this is saying that cause and effect states exist somewhere else. Instead, it's like I was saying before, it's that when a mechanism is exerting these constraints on its effect side, on its cause side, they have some value to them. It's saying the effect is going to be off, the cause is going to be off. So onness and offness are something. These are like qualities of the system in a way. They're not located in time or space or anything like that. They're just qualities of the units that constitute the system. And you use those same qualities to talk about the causes and the effects. And so they can be in common. You can have the same, you can have causes and effects that are made up of the same thing.
Okay, maybe then as a sort of, then the time is running out. So I just want to ask another question. So this is one of the main figure in your paper, right? So out of this 8 units, if you unfold it, it's a really gigantic structure, and then you project it into this 3-dimensional space, and then it's related to what your statement about the relations, cause, effects, and the mechanism, and what exists. When I was reading this again, and I was a bit confused about this. So you say that this edge, for example, is two relations, right? I mean, two simplex, which means the edge.
I have to remember because not all the information is being given in the figure, but I think, so what the intention, I think, which I hope is written in a caption or something, is that this edge, it is a simplex, but it's a 4 simplex, right? Because this is the overlap between the cause and effect of CDE with the cause and the effect of DE, right? So there's actually a little tetrahedral relation between these two distinctions.
This one.
And of course, that tetrahedron, it has 4 faces. There's 4 triangular relations between the effect here and the cause effect here, the cause here and the cause effect on the other side, and so on. Someone's using some tools. Yeah. And then there's a bunch of two relations. What is there? 6 two relations.
Okay, but it's a bit too complicated. So let's step back a little
There's
bit.
actually a
So,
little bundle of relations. There's a simplex of relations between those, and it's all, the phi value there is the sum of all those things, which
yeah,
is not.
before even going to that, so I just want to understand this one first.
Yeah.
E and DE.
Yeah.
So in this case, what is it?
Again, it's a 4 simplex.
So this is 4 simplex.
Yeah.
And the 4 simplex in what sense? Again?
So that relation, but that's the relation between the DE distinction and the E distinction, right?
Right.
And so DE, its cause and effect overlap themselves, for one thing.
Wait. Before that, so D and E here, you have an overlap in terms of cause and cause, right? Which is E here.
Yeah. So basically, you have a overlap of cause of. There's 2 causes and there's two effects in this mix here, and they're related in every possible combination in this case.
Yeah. So in this case, you have these 4 relations.
Yeah.
And that corresponds to this 4 simplex.
Yeah.
Okay. All right. Then I think I understand.
The simplex is the 4 relation and all of its faces. You know, so it's not just the 4 relation. It's we might be using different terminology here, but if I say 4 relation, I'm thinking of that the relation between all 4 of those things. The simplex is that relation, and it's also each little subset of 3, and it's each pair and so on. That's the simplex. It's a set of relations.
Yeah, I'm a bit probably losing this terminology, but anyway, in the case of the E and D, you have all these 4 relations, and somehow and then if you compute the sum of these, then that's this value.
Yep.
Right. And then in the case of CD and DE, you also have all these cause, effect, effects, and cause, effect, cause, and that's summed up to get this 10.7.
Yeah.
And then same goes here as well, right? And then here you have this one.
Yeah, and so that's a 6. So now that's a relation of 6 parts.
But what does it mean actually? So CD and D and E. So you're simultaneously thinking about all of these things. And then for the cause part, or okay, so maybe I started to probably understand this as I go through this. So you can have either cause or effect for each of them, right? Probably E cause, DE cause, and then CDE cause. Then you have an overlap of E.
Yeah.
Because you have E for all of them. And then for both effect, you also have E.
Yeah.
And then you go through all other 6 possibilities, possibly, right? Like cause, effect, cause, and then cause, effect, or something.
Yeah.
Okay.
And that's all the 3 relations, but there's
So this is called 3 relations.
Yeah. So I mean, when I say that, I mean, so a 3 relation, that's a relation of 3 things, right? Cause, effect, cause, effect, whatever. And so we're talking about simplexes and stuff. So this might be too much of a weird detail because it's something it's hard to make anything of it. It's very abstract, but something special about spatial structures is that every mechanism has a cause and an effect on itself, basically, right? And so that means that whenever you have several different mechanisms or distinctions that overlap, a consequence of that is that now the overlap is going to be over all of them, right? You're going to have, if you have 10 distinctions put together, then you're going to have a relation of the maximum order there, which is going to be a 20 relation because you have a cause and an effect for each of those 10 relations. And then every single subset of causes and effects is going to be a relation. So it's this big, it's a 20 simplex because the whole thing is related. Every part of it is related. That's not necessarily true of, cause effect structures in general. It can be hard to find such high order relations because the causes and effects can be disjoint or put together in weird ways. But with the space, it is the case that if any of them overlap, they're all going to overlap on those units. So there might be some extent to which this is a special case. Although I think that the reasons why are made pretty clear in the figure in the paper.
I see. Okay, I started to understand it, but I still need to understand a little bit more. But anyway, today probably it's, I guess, given the time, it's enough to finish it for now. Do you want to say anything to summarize today's interview, or shall we continue at some point? Maybe when I come back.
We can continue. I mean, I hope it's clear. Yeah. On the one hand, I hope it's clear why the relations are necessary and how they ideally correspond between like the phenomenal and the cause effect structure. But it's also true that, I mean, you can see from this that when you start looking at the cause effect structure in terms of its relations, it's rich, dense beyond comprehension. And that's something I don't know what to make of it. That's just the way, if that's the way experience is, that's just the way it is that it just has this vastly fine-grained, dense relational structure, which may or may not be something that's like subjectively obvious, I don't know. There's just kind of like an admission that this can start to look really complicated really fast when you think about it.
Okay, thanks a lot. We'll then just finish the recording for now. All right. Thank you.